This is video 3.4, and the goal is to solve equations with square roots, perfect squares, and absolute values by undoing and looking inside. Examples of solving equations with perfect squares are equations where something is squared. So in this case, x minus 4 is squared and it equals 25. Now our number one strategy for solving this is going to be undoing. Okay? Looking inside is often a good strategy as well, but sometimes we might forget things or sometimes we don't know our quick facts. So undoing will allow you to get the answers real quick even if you don't know the facts by heart. So undoing, remember undoing is when you undo each piece to get to your final answer. So when looking at the example here, x minus 4 squared, I'm going to undo the squaring first because it's on the outsidemost thing. And we should know to undo squaring, you square root both sides. Because what I do to the left, I have to do to the right. So I square root the left, and it gives me x minus 4. Okay, because the squaring and the square root undo each other. That's the whole goal. But then I have to look at the right. What is the square root of 25? Well, hopefully you know that's 5. But here's where the trick comes in. There's two ways to get 25. One is 5 and one is negative 5. So my two solutions at this point are 5 and negative 5. Because negative 5 squared gives you 25, and so does 5 squared. So these are two solutions that happen when I square root both sides. They could be 5 or negative 5. But now it's easy. Now I just solve for x. So I have two equations that I simply need to add 4 to see that one answer is 9. And the other answer, if I add 4 to both sides, x is negative 1. So I get two solutions here. X is 9 and x is negative 1. These are my two solutions to this particular perfect square equation. The next one. So that's when it's written. Notice how it originally was written. It was written as a perfect square. So the perfect square was alone and 25 was on the right-hand side. But if we look at the right, we have a lot more going on. We have the square, we have the 2, we have this other 2. Okay, it is not written alone at all. So I have to square root last to always undo in the opposite of the order of operations. So we're going to undo backwards in our order of operations. We're going to undo the 2 that lies here by subtracting it from both sides. Get the 2 out of there because it's simple. That makes a 0. And now I have 8 equals 2 parentheses x minus 5 squared. Now I'm going to undo the other 2. Well, let's see. This 2 says 2 times this quantity. So to undo it, I divide because it makes a nice big 1. But I have to do the same thing to the other side. So now my x minus 5 is alone. X minus 5 squared, that is, equals 8 divided by 2, which is 4. Okay, my next step is to undo the squaring that we see here. So I'm going to undo the squaring that I see there by square rooting both sides. But the minute I square root, I have to remember that it could be positive or negative. What's inside here could be positive or negative. So that means my x minus 5 could equal 2 because the square root of 4 is 2, or x minus 5 equals negative 2. So those are my two solutions. Now I solve for x. So in both of them I'll add 5, and I'll get one answer is 7. And the other answer, if I add 5, x is 3. So here are my two solutions to my problem. So now we get to points where we have to solve equations with square roots. And the number one strategy for doing so is undoing. So we're going to undo square roots in order to solve equations that involve square roots. So the first example, square root of x equals 8. What I'm going to do is I'm going to undo the square root. So the opposite of square rooting is squaring. So I'm going to undo that by squaring not just one side, but both sides. I'm going to square both sides because that undoes the square root. That leaves me with x alone. The other side is 8 squared. That is 64. Now I should be able to check my answer. Apparently I'm done. It was that easy. I should be able to check. If x is 64, I can put 64 right here and see if I get 8, like I'm supposed to. So I'm going to take the square root of 64, and I'm going to ask myself what number squared gives me 64, and the answer is 8. So it is in fact right. This is the answer. The 64 is a solution to my equation. Undoing. That's what we're going to do to solve rational expressions, rational equations like this. This second one is a little bit different. Notice where your square root is. We got some more stuff going on. It's not just x inside. Okay, but I'm still going to slowly undo things. The first thing that I want to undo, though, is the 2. I want to get rid of this 2. So think this 2 is actually 2 times the square root that you see here. So to get rid of that, I'm going to undo it by dividing. Divide. I'm going to cancel it out. Makes a big 1. I'm left with square root of y plus 2. I still have that. Equals 4. Now that should make sense because 2 times 4 equals 8. So that should make sense that this square root here should in fact be the same as this 4 here. They should be equal because 2 times this guy, 2 times this guy gives me 8, just like it's supposed to. So that's some other reasons why that definitely has to be 8. Has to be 4 to make it 8. So now I'm going to undo the square root because I have the square root alone. So I'm going to undo the square root by squaring both sides. That is the way to undo square rooting. I am left with y plus 2 on the left. It just cancels that out. It's kind of like making a big 1. And I get 4 squared on the right. But that's equal to 16. And then I'm going to do one more step to get my y alone. Take off 2. And y is 14. And there's my solution to the second problem. I'm going to definitely check my answers because this is very new to me, so I'm going to check my answers. Remember our problem was 2 square roots of y plus 2 equals 8. So if I plug 14 in, I should get 8. And so by checking my answer here, it looks like I do the square root of 16. I have to do the square root before I multiply by 2, so I'm going to get 2 times 4. Square root of 16 is 4, which equals 8. So my answer checks. 14 is my solution to my second equation. We're first going to review what the definition of absolute value is. So let's take a look at that definition. The definition is the distance from that number to 0. So when we're talking about the distance, we want to remember distance is always positive. So the absolute value of 10 would be 10 because it would take 10 steps to get to 0. But what's interesting is the absolute value of negative 10 is also 10. So the important thing here, remember, absolute value is always positive. So let's take a look at the best strategies for solving. The 2 best strategies for solving absolute value equations are looking inside and undoing. So you've seen some undoing already today. We'll do undoing with harder problems, but look inside is going to be a strategy that might be really easy to use on occasion. So look inside. These first 2 examples, we look inside to the absolute value of x, and it has to equal 13. So we think about what could the x on the inside of the absolute value possibly be. And if you remember, the values could be positive or negative 13. And that's because both of those are 13 units away from 0. So those are my 2 solutions. So I just thought about what could be on the inside to make that possible. The next example, absolute value of x minus 5 equals 11. Again, I think about the inside. X minus 5 this time is on the inside. And I think, okay, what could that inside be so that I get 11? Well, it could be positive 11, because if the inside was 11, then I'd get an answer of 11 for the absolute value. And I'm going to solve for x and find out what x is to make that answer 11. And to do that, I'm going to add 5 to both sides and get an answer of 16. And that would make the inside positive 11. But there's another solution on our hands. because while 16 minus 5 equals 11, and the absolute value is 11, there's another way to get an absolute value answer that equals 11, and that's when the inside is negative 11. So I'm going to set up that second equation and ask myself, when is the inside negative 11? Because that also has an absolute value of 11. And then I'll solve for x by adding 5 to both sides and getting the x alone, and I'll get an answer of negative 6. Because when I plug in negative 6, the inside of the absolute value will be negative 11, making the actual answer 11 when I take the absolute value. So the two solutions to this absolute value equation were 16 and negative 6, because they both work on the inside to give me an absolute value of 11. So in example 3 and 4, they both contain some stuff on the outside of the absolute value. In this case, this one contains a 2 on the outside of the absolute value of x. So my goal is to get the absolute value of x alone, just like I've written in red here. Since it's 2 times the absolute value and 2 times something, the way I undo that is by dividing both sides by 2. That undoes the 2 on the left, but I have to do it to the right as well. Then I get my absolute value of x alone, and it equals 16, because 32 divided by 2 is 16. Now I can use the strategies I've used before, like looking inside and just asking myself, what ways will give me an absolute value of 16? Well, I know if I put 16 in there, I get 16. But the other solution is negative 16, because the absolute value of negative 16 is also 16. Now example 4. This one looks more tricky because there's more stuff going on, but I'm going to start with undoing. I'm going to start with getting the absolute value alone. So that 3, I'm going to take care of that 3 on the outside first. And the way I take care of it is undoing it. So I'm going to undo the 3 by dividing both sides by 3. Once I do that, then the absolute value of 2x minus 8 is alone, and it equals 10, because 30 divided by 3 is 10. Now I'm going to break it up by thinking about what the inside has to be. So the inside, 2x minus 8, has to be either 10 or negative 10. So the inside, that stuff on the inside has to equal 10 or negative 10. So I'm going to solve that first equation and ask, okay, when is the inside 10? By writing 2x minus 8 equals 10 and solving for x. Add 8 to both sides, you get 2x equals 18. Divide both sides by 2, you get x equals 9. So that's one of my solutions. But we can't forget about the other solution. The other solution is when the inside is negative 10. So when is the inside negative 10? Because that also gives me an absolute value of 10. So I'm going to write another equation, 2x minus 8 equals negative 8, 10. And then I will solve that equation in the same exact steps by adding 8 to both sides and dividing both sides by 2. And I get my second solution of negative 1. So the two solutions are negative 1 and 9. Both of those will create an expression that's equal when I plug them in for x. So remember, when you're solving a lot of these equations, sometimes there's multiple solutions and sometimes there isn't. So be very careful and think about what could that inside be whenever you're trying to look inside. But always undo what's on the outside first before you look inside. So good luck. Make sure you ask your teacher lots of questions before you hand in your assignment and take your concept check.